Okay, so today I'm going to go over your checkpoint with you. Your checkpoint sheet was the 8 questions here for checkpoint 1. So question 1 asked you to find the slope between these 2 points. And then once you found that slope, you needed to find the y value when the x value was 4. So the first thing we're going to do here is we're going to find the slope between these 2 points. And this is where we're going to use our y2 minus y1 over our x2 minus x1 formula. Now, it really doesn't matter which one you call y2 and y1. The key is whatever point you start with for the y coordinate, you have to start with that point for the x coordinate. Meaning, if I started with 18 on the top, so I have 18 minus a negative 6, on the bottom, I have to start with the 2 now. If I started with the negative 6 on the top, if I did negative 6 minus the 18, on the bottom I would have had to start with the negative 4. So you have to start with the same point for both spots. And so there's how we could set it up. Now remember, minus a negative means plus, so this is going to become 24 over, this is not a 6, it's actually a 4. And that equals 6, so 24 divided by 6, and you get 4. So 4 is the slope. Now to find this one, when x is 4, well, I know what it is when y is 2. When x is 2, y is 18. So if my slope is 4, that means at 3, it would be 4 higher. So what is 18 plus 4? Well, that would be 22. And then if I go one more, the next point has to be 4 higher. That would give me 26. So 26 is what your answer should be on the second part of that question. When x is 4, the y value is 26. The second question was to find the slope from this linear scenario. Now this one is in standard form, so we can't just say it's 8. It's not in slope-intercept form. So to figure this one out, put it into slope-intercept form. So again, there's my slope-intercept form. So I want to get y by itself, and the number that's with the x is my slope. The other value, the b value here, is the y-intercept. So to get y by itself, the first thing I'm going to do is move this 8x, and I'm going to subtract it over to the other side. So these 8x's eliminate themselves. And now on this side, I have 12 minus 8x. I can't put those together. They're not like terms. The last thing I have to do is to get rid of multiplying by negative 2. I'm going to divide by negative 2. And you would get negative 6 plus 4x. So there's what that same line is in slope-intercept form. The part I want is the part with the x. So our slope here is a plus 4. So 4 is the slope of this line. Question 3 was to make an equation of the line that passes through those 2 points. So I want to make the equation, so I want to make the y equals mx plus b of the line that passes through those 2 points. So my first step is I've got to find the slope. So I'm going to do that the same way I did on number 1 up here. So I'm going to do y2 minus y1. So negative 4 minus 6. On the bottom, I have to do 3 minus negative 2 since I started with the negative 4. And you get negative 10 divided by 5, which is negative 2. So your first step is to find the slope, which we did. Now, we've got to find the b value. And what we're going to do here is we're going to use the slope, and we're going to use one of our given points. If we take a look, y equals mx plus b. The m is the slope, which we already know that number is negative 2. X and y are all the point pairs that fall on the line. So what I can do is I can plug a number into these 3 spots, and it allows me to solve for this fourth one. So I'm going to pick one of these points to use. It really doesn't matter which one we pick. I'm just going to go ahead and use the 3, negative 4. So instead of y, I'm now going to put that point's y coordinate. So that y coordinate is -4. So now -4 is going to go in the spot for the y. The m is what we just found. And now the point I'm using, the x coordinate, is 3. So there is how we could set this up. So now -2 times 3 is a -6. And now to move a -6, we would have to add it. And there's the y-intercept. So now we have the slope and we have the y-intercept, so now we can make the equation. So -2x plus 2 is what the equation should be on that one. Now, question 4 said find the slope and create the equation for the line that represents the given data set. So as we look at the data set here, what pattern do you notice? Well, -3 to 1, 1 to 5, 5 to 9, 9 to 13. You should notice here the pattern is the y values are adding 4 each time over and over and over again. That's what makes it linear. So the answer for the first part, the slope, is 4. Now, we want to make the equation. So I need to know what the slope is, which I do, and I need to know what the y-intercept, which I do. In this data set, I gave you the y-intercept. I know this is the y-intercept because y-intercepts occur when the x value is 0. So I know the y-intercept is 5. So y equals 4x plus 5 would be your equation for that data set. Alright, and we can check it real quick. So let's plug in 2. If I plug in 2, I should get 13. So if we plug 2 in, 4 times 2 is 8. 8 plus 5 does give us the 13. Question 5 was putting this equation that's in slope-intercept form back into this standard form look. So we want it to look like number 2 started. This 8x minus 2y, that's in standard form. So if you notice, there's no fractions here. So first thing I'm going to do is I want to get rid of this fraction. So I only have one denominator. So to get rid of it, I'm going to multiply everything by that 3, that denominator. So now I get 3y. Now 3 times 5/3. The 3's cross out, leaving us just the 5. But if you can't think of it that way, what's 3 times 5? That's 15. And then 15 divided by 3. And then 3 times the 2. So when you multiply this equation all by 3, you get this part. Now I just need to get x and y on the same side. So I'm going to subtract this positive 5x over to the other side. And this one is perfectly acceptable. The other way you might see this, especially on the SAT, is for some reason they like the x value coefficient to always be positive. So if you notice what I did on this one is I changed all the signs. So here it was -5, now it's +5. It was +3y, now it's -3y. +6, -6. These two equations are the exact same line. You wouldn't see this on the SAT, even though this is perfectly fine for me. This is the equation you would see on the SAT. So either one of these would work and put this into standard form. Question 6 is like question 4, except what you should note is I didn't give you the y-intercept in the data set. You would have to figure that out. So the pattern is we're subtracting 5 over and over and over again. So there is your slope. So a few ways we could do this. One way is we're pretty close to when x is 0, so we could actually backtrack. So instead of subtracting 5 to go backwards, I could add 5. So at 3, it should be 5 more than 36, which would be 41. And then 2 is going to be 5 more than 41, which is 46. At 1, it should be 5 more than 46, which is 61, or 51, excuse me. And then at 0, it should be 5 more. So at 0, we should be at 56. And so your equation would be y equals, your slope was -5, and your y-intercept was 56. So -5x plus 56. The other way you could have done this was pretty much like we did up here. I could have used my slope. So I'm going to plug -5 in for the m. And now I could pick one of my point pairs. If I just use the first one, so the y is 36 and the x is 4, I could have also figured it out that way, algebraically. So -5 times 4 is a -20. Add the 20 over, and you'll get 56. So you could have figured it out that way. Or, again, a quick way to do this would be, I got to go back 4 spots, so what's 4 times 5, which is 20, so I would have to go back and add 20 to 36 to get there. So a lot of ways you could have come up with this answer. Question 7 is the x-intercept is where the graph crosses the x-axis. What do we know about the y value at this point? Well, we know that anytime we have an x-intercept, the y-coordinate is always equal to 0. So then the second part was to find the x-intercepts to these two equations. So all I'm going to do is plug 0 in for the y, and I'm going to solve it for the x. So on our first example, there's how we would start it. And now I'm going to subtract 12. And I'm going to divide by 3. So the first one has an x-intercept of -4. Same thing over here. I'm going to plug 0 in. For the y. And now 6 times 0 is just 0. So what I have is just 4x equals 12. So this one has an x-intercept of 3. And then our last question is our good old rectangle problem. So it says the rectangle has a perimeter of 22 centimeters. The length is 3 more than the width. What is the area? So for the area, you need the length times the width. I know, buddy. Just a second. So I'm going to call the width W. I'm going to call the length W plus 3. So there's the picture we would have. So again, we were told the length is 3 more than the width. So I'm going to call the width my base variable. I'm going to call the length 3 more than it. So now the perimeter is 22, which means if I add up all my sides, which combine like terms, so I have 1, 2, 3, 4 W's, and then I have a 3 and a 3, so plus 6. That needs to equal 22. There's your equation. So if you solve this, subtract your 4, and subtract your 6 and then divide by 4, you get W, which is the width, to be 4. Now the length is 3 more than that one. So what's 4 plus 3? Well, 4 plus 3 is 7. There's your length. So now to find the area, you multiply those two numbers together. And so the area of this rectangle would be 28 square centimeters.